Keep going. And then once you've done 4, do 6, please. You have it? What's 4? If you put 4 in, what do you get? 15,000. And if you put 6 in, you should get 12,500. All right. We can write these as ordered pairs. So how do you write the first one? 0 and 20. Well, I just told you. 0 and 20 is going to be 0 and 20,000. The next one will be 2 and 17,500. Then 4 and 15,000. And 6 and 12,500. Okay. Are we okay with that? It's just completing a table of values like we did before. You're given an equation that describes it. You plug in your x or your y, or in this case, your t values, and it spits out the y value or the value of the function. We're going to plot them on this grid. So the input time, is that the independent or the dependent variable? Time is independent. Remember, the independent variable is always on the x-axis, which is always the horizontal. And the y-axis is the dependent, which would be the value here. Okay, so for time of 0, boom, 0, we have a value of $20,000, which is right there. You do it in a different color. Red. There's our first point. Our second point occurs at 2 years. T is 2, and we get a value of 17,500. So looking at the bottom here, each line represents 2. And then I go up to 17,500. So 17,000, there's 500. And then we go to 4 and 15,000. 1, 2, 3, 4, and 15,000. And the last one is 6 and 12,500. Which is right there. So essentially you get, can I fit it all in one? There. So you get something like that. Everybody get those points? Okay. Is this going to be a straight line or a curved line? How do you know it's going to be straight? Sorry? There is an exponent, but it's 1. On the t, the exponent is 1. So you know it's going to be a straight line. If you're going to draw a straight line, and you know how to determine if something's going to be a straight line from now on, you only actually need 2 points to plot. Okay? And then you can draw the whole line. Can we connect this line, or can we connect these points with a line? Does it make sense? No. So this is a discrete or continuous variable situation. Remember, discrete was like number of people. You could only have whole numbers, basically. And continuous means it could be anything. Is this discrete or continuous? Well, what's the denominator down here? Or sorry, the variable in the x. It's time, right? In years. So is that discrete or continuous? It's continuous, right? Time is always continuous, right? You can have 2.1 years, 2.2 years, whatever. It's a weird way to measure years, but you can still do it. So we can connect all of these with a straight line. So take out a ruler, please, and connect them with a straight line. Ugh. It's hard to do this with a ruler on here. Ah! Stop moving. Oh, I know. That is not a good line, but we'll live with it. All right, did we get that? Something that looks like that? All right, we're going to answer some questions here. So, what does the ordered pair 0 and 20,000 represent? It's okay, the y-intercept, let's go with that. It is the y-intercept. But what does that represent in terms of the car and its value? What is that point? What does this point represent? It's how much the car was valued when you first bought it. It was the cost of the car, essentially, right? So it's the cost of the car, the price of the car. Okay. Because time is 0. That's when you paid for it. Then as soon as you drive it off the lot, what happens to the value of the car? It starts decreasing. What does the t-intercept, i.e., so t is on our x-axis. So this is the x-intercept. What does that represent? This number right down here, it should be about 16 years. So what does that number represent? Ruth? When the car has no value. Now, that's not really realistic, but for the purposes of this, it's when the car has 0 value. All right? Its value is 0. Okay. Use the graph to estimate the value of the car after 3 years. So, if I want to know the price of the car after 3 years, not using the equation, okay, guys, I'm going to find 3 on my graph. So, find 3, which is right there. Oh, that's 2. I can count. So we find 3. That's 3 years, that blue dot. Then go up until you hit the graph, which is way up here. 1, 2, 3. It's about there. And then go across and get the value of the car. So after 3 years, it has a value of $16,000. Can you do 10 years? How much will it be worth after 10 years? Just approximate it, obviously, because everybody's graph is going to be slightly different. Yeah, I don't know. I'm just going to say 7,000. I'm just going to go to the nearest 1,000. Yours is at half. Mine's not at half. Everybody's going to have a slightly different number for this because everybody's line's going to go through this point at a different value because drawing a line freehand isn't the most accurate. Yes, Ruth. I didn't what? I haven't done 14 yet. Is that what you're asking? I didn't do 6. Oh. Probably should have. So it's like right there or something. I thought I did it, but how much is the car worth after 14 years? Approximately. Everybody's going to have a slightly different, because everybody draws the graph slightly differently. Okay. So 2,000. All right. I got about $2,000. Okay. Now, we can use our formulas to check this. All right. Doing it off the graph is not always the most accurate, especially if we draw it freehand, because everybody's going to have slightly different things. So our formula is, what is our formula? 20,000 minus 1,250. 1250t. Okay. I need one more zero. There we go. Which one do you want to verify? We'll only verify one of them. Which one? All right, let's do 10. So we'll verify 10. Put 10 into the formula. $7,500.
I was right. I was right.
So 7,500 is the actual answer. And you can see my graph is horrendous because I got about $7,000. But the actual answer is $7,500. So if you need the actual, you use the formula, if you have a formula. But later on in these units, won't be this unit, we'll learn how to determine the equation of that graph. If I just give you a graph, you'll learn how to figure out the equation of it. Okay. Totally. Okay, let's go down to, let's do this one. $5,000. When will the car be worth $5,000? So this is the reverse of the one up there. I'm saying how much is it worth after 3 years? Now I'm saying it's worth $5,000. When will that happen? So we go to 5,000. I go down. We already know my graph is wrong. My graph is like 11.8, but we know that's horrendous. But I'm going to say it anyway. So Baldwin says 11.8. Let's find out. I know it's going to be 12. All right. So we can use the formula to verify this. Our formula is V is equal to 20,000 minus 1250t. So if I say, how long before it's worth 5,000, where do I put the $5,000? In for V, in for this formula. So I go 5,000 is equal to 20,000 minus 1250t. So this is algebra. If you are weak in algebra, you need to come see me because the next infinity units all involve lots of algebra. Okay? How do I solve for t? All right, so I take away 20,000. What? What's 5 minus 20,000? Negative 15,000 is equal to negative 1250t. How do I solve for t? Not subtract. Divide. And a negative divided by negative is a positive. What's 15,000 divided by 1250? 12. So I was very close to my 11.8 estimate. Not close enough for Daniel. All right. Okay. So let's complete this last sentence here. The original value of the car is $20,000. It depreciates. Do we know what that means? Goes down, lessens in value. by how much per year? Look at the formula. Here's the formula right here. 1250, $1,250 every year. $1,250 every year. Okay? And has no value after 16 years. Although we know this is not true. This isn't true. Math 10 is rigged. That says math 10 is rigged. You don't have to write that.
I can see the word is.
That hurts my feelings. There's an M. That doesn't even look like an M. That doesn't look like an A. That looks like an H. Ma-co is rugged. Ma-co is rugged. That's what that says, apparently. What if we zoom in? Still looks the same. Ma-co rugged. There you go. I don't know what that means. Or math 10 is rigged. Oh, now it makes sense. There we go. Okay. I want you to do question 4, but try question 4, please. That's the only question I want you to do, please.